Right, let's commence our thinking about systems thinking by firstly thinking about systems. Russell Ackoff, who is a giant in the field of systems thinking, gave us a very, very good definition of what a system is. He said that a system is a whole that consists of two or more parts, and those parts have got three properties. Firstly, each of the parts can affect the behavior or the properties of the whole. So, for example, you as a system are affected by your heart and your lungs. Secondly, the parts are all interconnected. No part has an independent effect. For example, the lungs affect the heart. And then thirdly, each subset can affect the behavior or the properties of the whole, but not independently. So he summarizes his definition of a system by saying that a system is a functioning whole that cannot be divided into independent parts. So, for example, you can't divide an elephant in half and produce two small elephants. Now, this is probably what's important to stress here, in addition to your reading, is that we're looking at a system as an abstract concept. We're not looking at an IT system, we're not looking at an engineering system, we're not looking at a manufacturing or an industrial system or a concrete form of a system. What we're looking at here is we're looking at a system as an abstract concept, as an abstract whole constituted of abstract parts. Ackoff further he expands on his definition by giving us a classification, and he says that there are fundamentally four different types of systems. And the way that he looks at that is he looks at the purpose of both the whole and the part, and that enables us to put them on a 2x2 or nest them. Firstly, he says that there are deterministic systems. These are, for example, machines or mechanisms, where in that particular case, neither the purpose of the parts is purposeful, the parts are not purposeful, and neither is the whole. Secondly, the next level out are animate systems. These are organisms, for example. In an organism, the parts provide a fundamental purpose, although the whole doesn't demonstrate, I should say, purposiveness on its own. The third layer of system are social systems. So, for example, organizations and societies. They are, in turn, constituted of both animate and deterministic or mechanistic systems. Now, social systems, the parts in social systems are purposeful. For example, in an organization, individuals have their own purpose, as well as the whole organization also has its purpose. So importantly, social systems, both the parts and the whole, exhibit purposefulness. And then finally, ecological systems, the whole has a purpose, although the component parts, Ackoff would say, don't exhibit purposefulness. So we can take this abstract model of a system and we can see that within any given environment in which you might be the observer, there are a bunch of parts. There's a boundary around the system that you choose to focus on. We might refer to that as the system in focus or the system of interest. It's the system that we're trying to look at the particular purpose of. Into that system, there are inputs from the environment. There are outputs to the environment. Each of those elements inside the system are interrelated to each other. They, in turn, are constituted of component parts themselves, all of which can be appreciated in the same recursive or fractal fashion. So a system exists in an environment. It's of importance to a particular person, namely the observer. It exists for some particular purpose. It has a boundary around it, which enables us to identify where inputs come in and where outputs leave from, and what elements are on the inside that are in interrelationship with each other. The systems concept is fundamentally recursive, which means that it can be abstracted down or it can be abstracted up. Finally, Donella Meadows, who was an American systems thinker, she asks us, how is it that you can know that you're looking at a system or just a bunch of stuff? So, for example, I'm standing in front of a bunch of books in a library at home. Well, it's not a system because the individual part, it doesn't conform to Russ Ackoff's definition of a system. So how do you know that you're looking at a system, not just a bunch of parts? Well, can you identify the parts? Do the parts affect each other? In the case of the library, they don't affect each other. Do the parts produce an effect that is different from the effect of each of the parts on its own. In other words, do the parts contribute to the properties or the behavior of the system as a whole? And then finally, she adds, does the effect or the behavior over time persist in a variety of circumstances? That's how you know that you're looking at a system.